So this video is going to be looking at how to use mole ratios in order to solve stoichiometry problems. Mole ratios are the heart of all stoichiometry problems, and they will always be used when you're solving using stoichiometry. The key piece of any stoichiometry problem is the balanced chemical reaction. And again, it must be balanced. If it's not balanced, you are not going to be able to solve the thing correctly. So after knowing that the chemical equation is balanced, the first thing you should do that's not obvious, is not usually taught, is you need to understand what the chemical equation is saying. It is always put somewhere there so you know what the chemical formulas are. So this chemical equation says that butane in a lighter burns in air, which is oxygen, to produce carbon dioxide and water. So usually students will know what water is, what carbon dioxide is, what oxygen is, but then this butane always throws people off because what the heck is butane? Well, the chemical equation tells you what butane is. Once you know what each part of the chemical equation is, then you have to read the question and find the given and find what you're looking for in the question. So looking at question 1, it says how many moles of butane, that's what we're going to be looking for. It says how many moles of butane are needed to produce 15 moles of water. So 15 moles of water are given, along with the chemical equation, of course. And what we're supposed to find is how many moles of butane are needed to produce that much water. So, solving these chemical equations using dimensional analysis, what we're going to do is we're going to start with our given, which is 15 moles of water. We write down the whole number with the unit mole of water. I like to use chemical equations in my formula rather than name because it helps me to find what I'm going to find later. Then what I'm going to do is I'm always going to multiply it by a mole ratio. Remember, a mole ratio comes from a balanced chemical equation, and you're looking to cancel off what you're given, which in this case is moles of water, and find what you were supposed to find, obviously. So I'm going to cancel off moles of water by putting the moles of water on the bottom and I'm going to find my given by putting moles of butane on the top. So we need to find a ratio then that relates butane to water. That is right here in the chemical equation. Here is butane. Here is water. So it tells me to use 10 moles of water will be produced when 2 moles of butane are reacted. Thus, I will cancel off moles of butane. I will cancel off moles of water, and I'll end up with moles of butane. Now it's just calculator work. You're going to do 15 times 2 divided by 10. In the calculator, 15 times 2 is 30, divided by 10 is 3. So you end up with 3 moles of butane. Apologies for the messy handwriting. I'm using a new app, but hopefully you guys get what's going on. So let's go ahead and do number 2 together. This time, before you see me do the work, determine what is given to you in the question and what is it asking you to find. Pause the video before you see the answer. So after reading the question, hopefully you determine that what's given to you is 12 moles of carbon dioxide, the chemical reaction itself, of course, as well as how many moles of oxygen is what you're supposed to find. Now, looking at the chemical equation, or the question, moles of butane seems like it might be something you are going to look at because it's in the question, but really all that's doing is it's saying you can use that chemical reaction in order to solve this question. So again, we're going to start with our given moles, 12 moles of carbon dioxide. Remember to write the unit and the substance. From there, you're going to multiply by a ratio. For now, go ahead and write your x and go ahead and see if you can figure out the ratio. Don't forget to pause the video, try to find it yourself before moving on. So when I'm writing my ratio, I'm going to cancel off moles of carbon dioxide. I do that, of course, by putting moles of carbon dioxide on the bottom. On the top, I'm going to put what I'm looking for. In this case, it's asking me to find moles of oxygen. So now that you know that you're looking for the relationship between oxygen and carbon dioxide, you're going to go to the chemical equation and find out where oxygen is and where carbon dioxide is. That's not carbon dioxide, so let me erase that. Where carbon dioxide is, and you're going to use those to write your ratio. So go and pause the video and write in your correct ratio. So you should put 13 in front of the oxygen, 8 in front of the carbon dioxide. Do not forget to put the moles. Do not forget to put the units. Then, carefully, don't do this just because you assume that you're doing it right. Look at your units. Make sure they cancel off correctly. And then what they do is just comes down to calculator work. This calculator work is going to say 12 times 13 divided by 8, and then you will receive 19.5 moles of oxygen when you're done. And there you have it. Practice more. Like any other chemistry problem, any type of other problem, it takes practice to get good at it. It takes practice to gain confidence. Once you get this down, you should find this easy. You should be able to get 100% on any quiz that uses just mole ratios, going from moles of one substance to moles of another substance. Good luck. I hope you don't need it.